Hey guys, welcome back. Today we're going to do FRQs that have graphs like this, and I'm going to give you a couple of hints, okay? First, sometimes the graphs are nice, neat lines like this, and you can find the area between the pieces if you have to, because you know the area formulas for area of a triangle, sometimes area of a trapezoid. So sometimes it's nice and neat like this. Pay attention, always read very carefully what the title of this is, and if they say anything else in the technicalities here. Let me show you what I mean looking at a different one. So this is the 2018 version, and if you need area under curve, then you can see this part. You could use trapezoid formula. You could use trapezoid formula here, but what would you do for the area of these pieces where it's curved? And well, you have to read very carefully. It tells you that this is G, and that G also equals this, which is the equation of a parabola, once you hit 3, which means you could integrate by hand if you have to, instead of doing area under the curve for that region, okay? Here's the other glitch for this problem. Again, just trying to warn you of it, but you got to make sure you recognize it in the future. Read very carefully what this is a graph of, and read the technicalities in the instructions. This is a graph of G, which is defined to be the derivative of F. So G is already the same as F prime. You've got to keep that in mind, okay? Now, a couple of other hints. They're going to ask you for these to find maximums, minimums, inflection points, stuff like that. Use your justifications. Always write your justification first and then look for the answers. Those justifications are free points, okay? And they help you find the answer. So be very clear about if it says maximum, you're looking for first derivative, 0 or undefined, and changes from positive to negative, and make sure you write it. If it says maximum on a closed interval, make sure you show the T-chart, okay? Everything that's on those justification sheets. Inflection point, make sure if they say inflection point, whatever it's the inflection point of. So let's say they say, this is not this graph, but let's say they say inflection point of K of X. Okay, if they say inflection point of K, you immediately write second derivative changes signs, and then go work it out from there. What is that second derivative? That's a separate thing, but get your definition, your justification, get that down first, because it helps you find the answer as well.